So now we're looking at an applied problem where we actually have equations. It says a hospital patient is taking 2 medications. A of T estimates the number of milligrams of medication A in the bloodstream T hours after a 400 milligram dose has been taken. So we have a polynomial function for A of T. It's a little too complicated in its current form to really start to look at transformations, and it could actually be a combination of multiple parent functions, which is a little beyond what we would write ourselves. It says B of T estimates the number of milligrams of medication B in the bloodstream, which is being administered intravenously over the same interval. So there's some sort of IV, right, and they're getting another medication, and this is a log function, parent function L of X, shifted 7 to the left, and vertical stretch of 100. So that particular equation models what's going on with that medication. Both functions are defined over the interval from 0 to 6. So our first question says, when is A of T greater than B of T? We're going to round to the nearest hundredth of an hour, and we're also going to explain what does it mean for A of T to be greater than B of T in the context of the problem. So I already have my 2 equations in the calculator. I would start maybe with a zoom 6. And you're going to see, you can kind of see something at least, but we can't see the full equations. So the very first thing that's easy that we can start with is setting our T value, I should actually have a T here as well, which is our X value to 0 to 6. So I'm going to go to window and go from 0 to 6. I can tell I'm also going to need to change my Y window. That actually doesn't make things better in terms of what I see, but at least my X's are correct. So the easiest way on this one is to go to my table and see what are those actual Y values from 0 to 6. So the biggest one that I can see in the table is 344. Maybe I use 400 as my maximum. I also have that information about 400 milligrams of the medication being administered. So my window looks pretty safe to do a 400, and I can always adjust if that's not high enough, but that looks pretty good. So we need to find when A of T is greater than B of T. If I do a quick check, A of T is in the blue. So I'm really looking from this time to that time, so I need to find those 2 intersections. So I go second, calc intercept. I'm going to find them from left to right, which isn't totally necessary. So I'm close enough now that I'm closer to the one on the left than the one on the right, so I can press my enter 3 times. And I see that that intersection point is at 0.73, 204.55. So these are my intersections. I probably wanted to write first that in Y1, I put A of T, and in Y2, I put B of T. So second intersection point, second calc intersect, and I will scroll over and I'm going to show you something here. I think that intersection is around X equals 4. So I can also press enter, I'm not writing on the enter button. So enter twice, and then on the guess, I can actually type in where I want to guess. I want to guess over at 4, and that will jump me over closer to that other intersection. So you can also use that guess feature and just type in a guess if you don't want to scroll. So I have 3.66, 236.66. So we know we want to be in between those 2 times. So I'm going to do my answer and my explanation at the same time. So from 0.73 to 3.66, those X values or T values are hours, and specifically they're hours after the medication A was administered, after medication A is administered. There will be more of medication A in the bloodstream. I'm going to abbreviate that. Than medication B. So that's the answer in the context of the problem. The answer is from 0.73 to 3.66, which I could write in subbuilder interval, but I chose to write it this way because I was explaining it anyway as a word problem answer. So we have another question for this one, and this is just going to get into some other stuff that we do with graphs that we maybe haven't done in a little while. So this says, what is the average rate of change and the amount of medication A in the person's bloodstream from the time when it reaches a maximum to where T equals 5. So I'm finding the average rate of change from here, where it reaches a maximum. And I will actually, medication B has nothing to do with this question, so I'm going to turn that graph off by unhighlighting its equal sign. So we can just focus on what we need to do. To the time when T is 5. So 1, 2, 3, 4, 5. Get rid of that. Or not. We'll move it off, I guess, is the best we can do right now. So I'm looking to where T is 5, so this point here. So an average rate of change is a slope of a line between 2 points. So we can see that the graph is pretty curvy between there, so the slope is changing. But if I directly connected these 2 points at the maximum and T equals 5, what's the slope of that line? So I've taken the slope formula, which is y2 minus y1 over x2 minus x1, and now I just need to know what those points are. So I'm going to use my calc menu, second trace, and the first thing I need to find is a maximum. So I'm going to do number 4. And I am going to erase this for now, just so we can see a little bit more what the cursor's doing. So I have to go left bound, which I can do arrowing over. I'm on the left side. If I wanted to type in my right bound looks like 3 should be fine. So I can actually type that number in. And if I want to guess, maybe I think the maximum is around 2. And I could use a decimal also. So I can enter those numbers. I know we started arrowing, we're just going to use this. So my max point, which I'm going to label, is 2.15, 345.76. I should be good if I keep those decimals. Another thing you can do is if you go to the home screen, you can take those values and store them. So that's my most recent x value for the maximum and my most recent y value. So I could keep the whole decimals in the calculator. Going back to my graph, I could look in the table for this number, but I'm going to use my calculate menu. So I'm going to calculate a value, second calc 1, and I'm going to type in the 5, and it will give me my y value, which is 66. So the other point we're doing is when the T is 5, we have 66. So with these numbers now, I can set up a slope formula. So I have y2 minus y1 over x2 minus x1. I could write those rounded numbers if I want to use my stored values. I have 66 minus, I stored that one as b, and I have, okay, still not letting me delete it, so we'll move it again. On the bottom, we have 5 minus a, and now we can press enter, and I get my answer, which is negative 90.1. Looking back, I don't have to explain it, but I do have to use correct units. So this is going to be negative 90.1. If I look back at these numbers, the top numbers are milligrams of medication, and the bottom numbers are time, and that's in hours. So we're doing milligrams divided by hours or milligrams per hour. So if we were going to explain this in the context of the problem, medication A over this time interval is decreasing by 90.1 milligrams per hour. If I look back at my graph, right, I can see that decrease. I know my Y scale, I went all the way up to 400, so that does sound like it makes sense.